Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the relationship between operators E and delta. So E is the forward shift operator and delta is the forward difference operator. So in general, delta of yn is given by y of n plus 1 minus y of n. So this is the basic formula of forward difference operator. And we know that E, that is forward shift operator, E of f of x is nothing but f of x plus h. So now here we are writing E in terms of f of x. So this delta equation we will also write in terms of f of x. Let's say our y is f of x. Then delta of f of x is nothing but yn of n plus 1, that is next term. And in y equal to f of x, the next term is f of x plus h. Here we will have f of x plus h minus f of x. So now we will find the relationship between the operator E and delta. So we have these two equations. So from this equation we will get f of x plus h, and we are going to substitute this f of x plus h in this equation. So we will get delta of f of x minus f of x equal to f of x plus h. When we equate this f of x plus h and this f of x plus h, we will get E of f of x equal to delta of f of x minus f of x. So E of f of x is nothing but delta minus 1. I am taking f of x common. So now we can cancel this f of x and f of x. We will get E equal to delta minus 1, or we can write delta equal to E plus 1. This is a very famous relationship between the forward difference operator and the forward shift operator, which will be asked in the exam in the first compulsory question for 5 marks. So this is the simplest derivation which you can expect in the exam. So this is one relationship between E and delta. There is another relationship between E and delta. So let's say if our d by dx is equal to d, then d of f of x is nothing but d by dx of f of x, which can be represented as f dash of x. Now we know E of f of x is nothing but f of x plus h. Here we are going to apply the Taylor's theorem. Taylor's theorem states that we can expand the term using Taylor series. So we will have f of x plus h upon h into f dash of x plus h square upon 2 factorial into f double dash of x plus h cube upon 3 factorial into f triple dash of x, and so on. This we have seen in the Taylor series method while doing the numerical methods. Okay, so you can remember from that. So now what we can do here, we can write this f of x. We can write this f dash of x. From here we can write it as d of f of x. So we will get f of x plus h of d of f of x plus h square upon 2 factorial. What will be f double dash of x? It will be d square f of x, which is the second derivative. D square means second derivative. So d square f of x plus h cube upon 3 factorial. Third derivative will be d cube f of x, and so on. So from this equation we will take f of x common. So we will get 1 plus h d plus h square upon 2 factorial into d square plus h cube upon 3 factorial into d cube, and so on. And outside we have f of x. What is the series of e raised to x? It is nothing but 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x raised to 4 upon 4 factorial, and so on. Now if you see in this equation, we replace x by hd, we get 1 plus hd plus h square d square upon 2 factorial plus h cube d cube upon 3 factorial, which is nothing but e raised to hd. So if you compare this term with this term is nothing but e raised to hd into f of x. So we get e raised to f of x as e raised to hd into f of x. So e of f of x is nothing but e raised to hd into f of x. You can cancel this f of x. We will get e equal to e raised to hd. And what is delta? Delta is nothing but e plus 1, which we just saw. We get delta equal to e raised to hd plus 1. So this is the second relation. So this is the relationships between operators e and delta. More such things we will see in our next video. So stay tuned for our future lectures.